If you're starting with backend development and want to clearly understand how APIs actually work in real world applications, then this video is for you. In this video, I will guide you step by step through building a simple student management API, connecting it to a database that is PostgreSQL and testing it using Postman. The goal here is not just to run the project, but to actually understand how each component works together. So, what exactly are we building? We are creating a simple student management API where we can perform different operations such as able to add new student, view all student, update existing student data, or if required, delete records. Before we go into understanding tools and code, it's very important to understand the flow of the application. Once this flow is clear, backend development becomes much easier. Now let's move to our first concept, that is REST API. REST API stands for Representational State Transfer. It is a way for different applications to communicate with each other over the internet. Now moving to our second concept, that is four-layer architecture. It is a design pattern used to organize an application into separate layers. Each layer have a specific responsibility which makes the system easier to understand, develop and maintain. Four layers of this architecture are controller, service layer, repository layer and database layer. First is controller layer. This layer receives requests from the postman. It decides which operation need to be performed. Then comes the business logic layer. This layer contains the core logic of the application. Then comes repository layer, it handles database, and then database layer, that is PG admin, that stores all our data. Now let's talk about database part. We are using PostgreSQL and PG admin. They help us manage it visually. We have created a database called studentDB and a table named student. Each row in this table represents a student and the ID field acts as a primary key which uniquely identifies each record. The important thing to notice here is that any change we make through our API will be reflected here in real time. Now let's look at its implementation in pgadmin. We will learn how to create a database, how to create a table, and then how to view our created table. Now we are on pgadmin. We can right click on our server and then go on create database. Here we can name a database. For now I have created a database called studentDB. Once the database is created, we can click on the database, then go on schema and open a query tool. In that query tool, we will run the following query to create a table called students. In the schema, we can see our table created called students. We can right click on this to see our output table. For now, our output table is empty as we have not inserted any data in this yet. Once we are done with creating our database, second thing we need to understand is a project structure, because this is the core component of our backend. In this, for now, we are making three main folders, that is controller. It will handle all API endpoints and will manage request and response from Postman. Second folder is models. Models represent database structure, include table name and column names like ID or name. Then comes our data folder. This folder connects our application to database. This is a folder that runs the query and also track the changes. Now let's talk about another important topic, that is entity framework. Entity framework is an ORM, object relational mapper. Normally we write SQL query to interact with database, but EF core allows us to use C hash code instead. For example, instead of writing a SQL query like select star from students, we simply write context.student.toList. This command lists all our students present in a table. So basically, ER core automatically converts this C hash code into SQL and execute it in the database. So we can think of EF core as a translator. We first write the code in C hash, then it translates everything into SQL query for the database. This makes development much faster, cleaner, and easier to maintain. Key concepts of our EF core are DB context. It acts as a bridge between our code and database. DB set. It represents a table in the database. Model. It represents the table structure, like how many columns we will be having in our table. Then CRUD operations, that are deleting our records, updating the data, or creating new records, or we just want to read our records. Now we can have a look at our code and the flow of our system. Firstly, a request comes to the controller, then that data is fetched using DB context and the response is returned in JSON format. Let's start with model. The model defines the structure of our data. In this project, we have a student class with properties like ID and name. Each property in this class represents a column in the database table and each object represents a row. Now let's look at the controller. The controller is responsible for handling API requests. It receives requests from Postman and perform operation based on the HTTP method. In this we have 4 HTTP methods. First is get to get all commands, then post to add new student, then further is put to update the student detail based on the ID. Then comes delete. Delete is to remove a student based on ID. Then comes DB context. It is one of the most important part of the application. DB context acts as a bridge between our application and the database. Here we define a DB set called students, which represent the student table in the database. Using DB context, we can perform operation like fetching, inserting, updating, and deleting data. Finally, we have program CS, which is responsible for configuring and running the application. In app.json, I have given my connection credentials. Now let's test our API using Postman. Firstly, let's get to know what exactly is a Postman. When we don't want to create front-end for a backend system, but we still want to test it, then Postman comes in the picture. It is a API testing tool used when we don't need any front-end for our project. It has 4 multiple HTTP methods. First is get. We send a get request to retrieve all students from the database. This helps us verify that our data is being fetched correctly. Then is post. We use post to add a new student by sending data in JSON format. I have also given an example of the response. Then comes put. We use put to update an existing student's data. This modifies the existing record based on the given ID. Then comes delete. Finally, we use delete to remove a student from the database. As you can see, every option performed in Postman is directly reflected in the database, which confirms that our API is working correctly. I will show you the implementation in a while. While working with APIs, it's completely normal to encounter errors. Some of the common errors I have mentioned: if we get status code starting with 1, then it is an informational error. We don't need to worry about it. If it starts with 2, then our request that we have executed is successfully done. If it starts with 4, then it's a client based error. It can be bad request, not allowed, or method is not allowed, not found, unauthorization, and so on. If it starts with 5, then it is a server error such as internal server error, service unavailable, or gateway timeout. Now we can have a look at the implementation. After running .NET on our terminal, we have to copy the local host we will get and paste it on Postman and add API/student in front of that. Now we will start with get. As we click on get, we can see the records we have posted so far. Then we can go on post. Post is used to add new data. As I have changed the ID and name, we can see we have successfully added the new data. We can also check it through get. We can see 2 entries so far in our database. Then we can go on put. As we have mentioned that we will be updating our data based on the ID, so we can just type the ID with student and then change the name of the student. After running it, we can see we have successfully changed the name. After clicking on get, we can see our updated database. Now after updating our database, we can go on pgadmin to verify if our table is updated or not. We can see 2 entries here. Now we can try deleting one of the student. Let's say we are deleting student with ID number 2. We can go on get to check our database. For now, in our database, we can see we have only one entry. Now we can see the same on pgadmin as well. We can go on server, then right click on our table to refresh our database. Once we refresh our table, we can see the new updated table and we are left with only one entry that we didn't deleted. So now we can say that our project is successfully connected. Now we can conclude that our project is successfully done. So to conclude, in this video, we have successfully built a simple backend API that is connected to a PostgreSQL database and is tested using Postman. We also understood how model, DB context, and controller work together to handle requests and manage data. If you understand this flow, you now have a strong foundation to start building your own backend application. Try experimenting it, add new features, and explore more. And whenever you feel stuck, just come back to the basic flow. Now discussing about future enhancement, we can add authentication or front end. We can also learn to deploy our project to cloud. This will optimize our performance. Thank you for watching.